Hello everyone. For this tutorial video, I like to explain universal time constant formulas you can find to calculate voltage and currents in either inductors or capacitors at specific times. In particular, a time constant in a circuit has a very specific definition of the amount of time it takes for either a voltage or current to become exactly 63% of the total voltage or current in the circuit. If we remember for capacitors, the greater the capacitance, the greater the resistance to changes in voltage. Then this should logically mean it would take a longer time to reach the same exact value. But in a circuit where it is in series with a resistor, the resistance would also affect the time as well, because we know for simple resistors, ignoring the capacitor, the greater the resistance, the greater the voltage drop. So this would mean the greater the resistance, the more time it would take to charge to the same level, just like the greater the capacitance. So we conclude that tau for time period equals R times C for a simple resistor-capacitor circuit. If we remember from the previous tutorial video, inductors drop voltages in the opposite manner that capacitors do. We should be able to safely conclude that tau equals inductance over resistance. And since we already went over the thought process for resistor-capacitor circuits, I do not feel a need to reiterate it for inductor-resistor circuits. Although the 63% rule may seem arbitrary and confusing, this actually comes from a specific formula that comes from the shape of the graph, which is called the universal time constant formula, and its percent change over time is 1 minus 1 over e to the power of t in seconds over the time constant for the circuit, times 100 because it is a percentage. So when we do the math where the ratio of t over time constant equals 1 exactly, we get 63% just about. And as we get closer and closer to an infinite amount of time constants, or an infinite time in total, we get closer and closer to 100%. So this formula works nicely as a universal answer for simple capacitor or inductor circuits. Now that I've explained the universal formula for transients, I can transition away from direct current problems and toward the study of alternating current, which is important for not only inductors and transformers, but is also important for electrical design in homes in general, because of how power lines that go to your homes are always alternating current and not direct current, because of how alternating current is more energy efficient, as we will see. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.